This is my report on our Physics 2211 Lab 1, Observing Constant Velocity Motion. For this lab, we had an experimental model where I used a ball rolling across the table and then a theoretical model using GlowScript and Python. For the theoretical model, we used Newton's second law, which states that force equals change in momentum divided by change in time. The velocity update formula, which states that the final velocity is equal to the initial velocity plus the net force divided by mass multiplied by the change in time, and the position update formula, which states that the final position is equal to the initial position plus the average velocity times the change in time. The main result I observed was that the motion was in fact not perfectly constant when you take the experimental data and compare it to the prediction using the model. It was actually constantly decreasing. The experiment that I observed is a ball rolling across a table at a constant velocity. The positive x-axis was to the right with a 3-degree incline due to the placement and tilt of the camera. I used the plotting function of tracker to get the position as a function of time and use this to calculate my velocity. For this experiment, I used a lacrosse ball, which had a diameter of 6.35 centimeters and a mass of 150 grams. The initial position of the ball was negative 0.00100 meters. The first recorded position was 0.01700 meters at 0.033 seconds, and the final position was 0.47900 meters at 1.268 seconds, since the camera I used was going at 30 frames per second. The initial velocity is calculated by taking the changes in position over the change in time, which, using our initial position and the first recorded position, gives us an initial velocity of 0.489 meters per second. If we had flipped the axis and positive x became negative x, the only effect there would have been on my results is that my final position would be negative and my velocity would be negative. All the magnitudes and distances would stay the same, they would just have the opposite sign. For the model, we are assuming that velocity is constant and the net force on the ball is zero, which isn't necessarily true because, for one, the table may not have been perfectly flat, which would have led to the normal force affecting the ball's motion. Two, it is very difficult to pinpoint exactly where the ball is in tracker, and the angle of the camera could also affect this position. And three, we are assuming there is no friction on this ball, which would have an effect on the velocity since it works in the opposite direction to motion. In this model, you can see that velocity and position are updated each loop using their update formulas. And that for the velocity one, F net is 0, so the velocity will remain constant. Then this velocity is used to update the position every loop. The velocity used is 0.489 meters per second, which is the initial velocity from the experiment. I chose this velocity because since we are assuming that the net force on the ball is 0, the velocity should not change at all from the initial. When you plot the data next to each other, you can see the expected position ends up being greater than the observed position. This is due to the velocity not actually being perfectly constant in the experiment, but due to the low time frame, the difference in final position is not that great, being only 0.13 meters. For velocity to remain constant, the net force on the ball has to be 0. This can only happen when the force of gravity cancels out with the normal force, and there's no frictional force to act against motion. In this first diagram, you can see that there are two forces that completely cancel each other out, which means the net force on the ball is 0, meaning constant velocity. But in the real world, there's always friction, opposite motion, so the diagram would look like the one on the bottom, and the net force on the object would not be 0, leading to the discrepancy in the data. As you can see, the y forces cancel out, but there's this frictional force in the negative x direction that leads to a change in velocity. And these are the sources I used for my image. Thank you.